Hi students.
What are voids? Void means nothing. It is an empty place. It is an empty place among the spheres. Just like we take X-ray photographs to identify the gaps. What are gaps? Fractures in the bones. In the same manner, X-ray photographs can be taken for iron rods. We can identify the space among metallic atoms. This was identified in the year 1920 during X-ray diffraction experiments. See the gaps among iron atoms? Void is a gap. Void is defined as an empty place among the spheres. Void is also called interstice, site, hole, or gap. These are the types of voids. Let us go to the first void. Trigonal void. It is a gap among three spheres. This is the example. The blue color spheres are atoms. These have some empty place at the center. What is the largest spherical gap in that? That is called trigonal void. The white curved space indicates trigonal void. The coordination number is 3 here. It means each trigonal void is surrounded by 3 spheres. See the small sphere indicated by white color? That is small r. Blue color sphere is largest one. That is big R. Small r indicates radius of small atom. This is fitted in the void. Small r by capital R is 0.155. Radius of the void by radius of the atom. This is called limiting radius. In the case of trigonal void, this is the value. So spheres are negative charge. Cation can be fitted at the center, that is positive charge. Radius of the cation by radius of the anion. This is in this range in the case of trigonal voids. How to prove the limiting radius? That we'll discuss in the last of the video. Tetrahedral voids. It is a gap among the 4 spheres. Zinc sulfide is the best example. 3 spheres are there, blue colored. Let us place red color sphere on the top. See, among the 4 spheres, some gap is there, indicated by white sphere. That is called tetrahedral void. The white color sphere indicates white. That is a gap among the 4 spheres. The tetrahedral void has coordination number 4. What does it mean? Each tetrahedral void is surrounded by 4 spheres. Here, this is the limiting radius. In the case of tetrahedral voids, this is the range of limiting radius in tetrahedral voids. What is octahedral void? It is the gap among 6 spheres. Sodium chloride is the best example. See, the yellow color sphere, blue color spheres. Let us place yellow color sphere at the bottom. Take one more sphere, place at the top color sphere, top one red sphere, bottom one is yellow color. See, this is just like an octahedron. The gap among the 6 spheres is called octahedral void. What is coordination number here? 6. It means each octahedral void is surrounded by 6 spheres. This is the limiting radius in the octahedral voids. This is the range of limiting radius. It can extend from the lower value to higher value. Please remember this value. Cubic void, the last one. It is a gap among 8 atoms. Cesium chloride is the best example. See the cube? Each corner has one atom. Coordination number 8. Among the 8 atoms, what is the gap? That is called cubic void. Each cubic void is surrounded by 8 spheres. Let us take the 8 spheres. Now, among the 8 spheres, small gap is there. The white color indicates cubic void. What is limiting radius here? 0.7321. Now, what is order of size of the voids? What is the increasing order? This is the increasing order. See, these are the limiting radius. Increasing order of limiting radius. As the limiting radius increases, size of the void increases. Let us compare triangular void and cubic voids. Which has larger size? In this, cubic void is larger. Big cation can be fitted in the gap among the spheres. Largest cation can be fitted in the cubic void because cubic void is the largest among all atoms, all voids. Why? Because the limiting radius is very high. Let us meet in the next class. Thanks for watching. Drop a like, leave a comment, and don't forget to subscribe.